Hi, so this is Raghupati, uh, working as assistant professor in Government College of Engineering, Body Naikanur. So in this video lectures, I am going to present the corrosion and its prevention. This is one of the chapter in the unit number 4 of subject CE 8020, repair and rehabilitation of structures. So first let us see what is corrosion of steel. So ASTM is having its own terminology, that is corrosion defines as the chemical or electrochemical reaction between a material, usually a metal, and its environment that produces deterioration of the material and its properties. For steel embedded in concrete, corrosion results in the formation of rust, which has 2 to 4 times the volume of the original steel and none of the good mechanical properties. Corrosion also produces pits or holes in the surfaces of reinforcing steel, reducing strength capacity as a result of the reduced cross-sectional area of concrete section. Then this is the electrochemical process of steel corrosion in concrete. So normally any reinforced and prestressed concrete represents a very successful combination of material. So not only from a mechanical point of view but also from a chemical perspective. Then the natural state of any metal is in its oxidized state. So metal can be found in nature in the form of oxides, carbonates, sulfates. So actually for the practical use of a metal, a certain energy is invested in its reduction from the natural mineral state. So the process by which a metal returns to its mineral state is generally termed as corrosion. Actually, corrosion is therefore the process by which the metal passes from its metallic state at zero valence to its oxidized state, liberating electrons. So in which uh, for iron it can be simply said to be as in this equation, that is that equation is so that equation is Fe becomes ionized in terms of Fe plus 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 2E minus, which liberates the electrons. Then the electrons are transferred to other substance in order to become a neutral substance. So the mechanisms for transfer of electrons from the metal to another substance can basically occur in two manners. One is directly, or another one is through an aqueous solution. The former is produced at high temperature, that is the direct transfer is happened only in the produced of high temperature, where the water cannot exist in the liquid form for transfer the electrons. But while the aqueous corrosion is the most common mechanism and it develops at a normal temperature. So in this aqueous corrosion is done, that is transfer of electrons through the liquid medium. So in this concrete, this method of aqueous corrosion is happened generally. So corrosion in the presence of liquid water occurs by an electrochemical mechanism. So chemical reactions and the redox process occur simultaneously. Thus metallic zones with different electrical potential due to the metal begin in contact with the electrolyte, and which deriving the force of chemical reactions involving the exchange of electrons. Okay, yes. So the process occurs as in battery, where the oxidation of the metal takes place in the anodic zone. As we have already discussed in the that reaction, that is Fe tends to Fe plus 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 2E minus. Yes, and the reduction takes place in the cathodic zone. So in another manner, the cathodic zone is presented in the concrete. So that for the case of neutral and alkaline electrolytes, the most common cathodic reaction is given in this figure, that is O2. You see that this is the reaction takes place in the cathode region. O2 plus 2H2O plus 4E minus, which tends to 4OH minus. Okay, 4OH minus. Then what happened? The electrons liberated in the anodic circulate through the metal to the cathodic zone, where they are consumed, inducing the reduction of substance. Example, oxygen in the that cathodic zone. So the reduction means the final corrosion product would be FeOH of 2 and FeOH of 3, or some oxyhydroxide derived from them. So these are all the product of corrosion, that is FeOH of 2, ferric hydroxide and ferric hydrates. So for the case of acid solution, the most common cathode reaction in the reduction of protons. So the elements of corrosion cell in aqueous types are aqueous type corrosion are. So just I would like to summarize. The first one is the anode, where the metal is dissolved. Then the second step is the second process, the cathode, where a substance is reduced and take up the electrons liberated by the metal during its oxidation. Then third process, what is going on there? Continuity across the metal between anode and cathode. Then the continuity across the electrolyte for the chemical substance to move and become neutral. Then the lack of so these are all the processes are happening in the corrosion, okay, during corrosion. Then the lack of electrolyte or of metal connection will stop the corrosion and development of any anodic or cathodic zone. So this is the solution, the major solution for stop the corrosion. That is, we have to stop the transformation of this ionic chain. So then the next slide, corrosion in seawater. So normally the op structure is majorly affected by the corrosion which happened in the seawater due to seawater. Normally the seawater is subjected to chloride. Yes, it contains a lot of chlorides. Then what happened? The chloride enters into concrete, which forms the corrosion of steel. So normally the entering of chlorine, what in the form of gas. So what it is done? So the nature of concrete is entirely changed into acidic nature. So actually the nature of concrete is alkaline in nature, but it will be converted into acidic in nature, and therefore it is severely affected by corrosion, the steel in concrete. Then salt weathering. So salt weathering is also done in the concrete from the seashore. Then abrasion by sand. So the sand is also it is giving the frictional force when it is heated to the structure. So it is giving the frictional force, and therefore abrasion by sand happen. Then seawater contains some amount of CO2. So when CO2 enters into the concrete, then carbonation takes place. So that one leads to the corrosion of steel. Then calcium hydroxide and calcium sulfate soluble in seawater. Then rate of chemical attacks is increased in temperature. Then next let us see the carbonation. So what is carbonation? So this is a figure which shows which is affected by the carbonation. So the process of carbonation is taken like this. So let us discuss the carbonation. Carbonation of concrete is a process by which the carbon dioxide from the air penetrates into concrete and reacts with the calcium hydroxide to form calcium carbonation. So carbonic acid which attack the concrete. So the carbonation of concrete is one of the main reasons for corrosion reinforcement. Okay. Then what are the factors to increase the rate of carbonation? So the first one is grade of concrete, then level of pore water, then permeability of concrete, then whether the concrete is protected or not. So these are all the factors which increase the rate of carbonation. Then what are the effects of corrosion? The ultimately strength of the concrete is reduced. So the strength of the structure is also reduced. Then structure will failure. Then eccentricity is happen. Suppose if the joint in the joint portion will fail due to corrosion, the eccentricity is happen. Then cracks, spalling of concrete is also happen. The cross section of reinforcement progressively reduced, and therefore the strength carrying capacity, that is tensile strength carrying capacity of the steel gets tensile strength carrying capacity of the concrete gets reduced. Then the cover of the concrete is adversely affected. Then how do we control this? How do we control this corrosion of steel reinforcement? So let us see that one. The control of the corrosion of steel reinforcement is done by the metallurgical ecological method. Then we just use the corrosion inhibitors, then coating to reinforcement. Then we just make the de-rusting or phosphating coating to concrete. Then cement coating, sealing, fusion bond, epoxy coating, galvanized reinforcement, then finally cathodic protection. So what is metallurgical method? Steel can be made more corrosion resistant by altering its structure through metallurgical process. So basically, if once the manufacture of steel itself is having own resistance against the corrosion, like that we just manufacture this steel. So that is the metallurgical method. So there are many situations where stainless steel reinforcement are used for long-term durability of concrete structure. Then corrosion inhibitors. Corrosion can be prevented by chemical methods by using certain corrosion inhibiting chemicals such as nitrates, phosphates, then benzoates. A most widely used admixture is based on calcium nitrates. It is added to the concrete during mixing of concrete, and therefore the steel is protected by a layer of ferric oxide on the surface of the steel. Then coating of reinforcement. So the object of coating of steel bar is to provide a durable barrier to aggressive materials such as chlorides. So the coating should be robust to withstand fabrication of reinforcement, catch and pouring of concrete, and compaction by vibration needed. Then de-rusting. The reinforcement is cleaned with a de-rusting solution. So once the rods gets corroded, when it is placed on in exposed condition, so before placing the reinforcement, if it is having any formation of rust, it should be cleaned with a de-rusting solution. So this is followed without delay by cleaning the rods with the wet waste cloths and cleaning powder. The rods are then rinsed in running water and air dried. Then phosphate is applied to the surface, and an inhibitor solution is then brushed over the phosphate surface. Then let us give the cement coating. Slurry is made by mixing the inhibitor solution with water and cement and applied on the bar. So the sealing solution is brushed after the rods are air cured. So the sealing solution has an inside curing effect. The second coat of slurry is then applied on the bars or air dry. So this is the another method or another way to reduce the corrosion. Then sealing solution. So 2 coats of sealing solution are applied to the bars reinforcement, that is rebars, in order to seal the micro pores of the cement coat and to make it impermeable to corrosive salt. Then we are also using the epoxy coating. So it is one of the effective method of coating on the rebars, carrying out in a factory and not at site work. So this epoxy coating should be done in the factory, not at site of work. In the epoxy coating, the plant are designed to coat the straight bars is a continuous process. The epoxy powder particles are deposited evenly on the surface of the bars. Then the epoxy coated bars have an excellent protection to corrosion in aggressive environment. After treatment, cutting and bending may injure the steel. The coating may get damaged during vibration of concrete. So then galvanized reinforcement. The galvanized reinforcement consists of dipping of steel bar in molten zinc. So the coating of zinc bonded to the surface of steel. The zinc surface reacts with the calcium hydroxide in the concrete to form a passive layer and prevent corrosion. Then next, let us very important method, that is cathodic protection. Is one of the effective, well-known and extensively used methods for preventing corrosion in concrete method. It is high case and long-term monitoring required for this method. So the cathodic protection comprises of application current to an electrode laid on the concrete above steel reinforcement. So let us discuss about the cathodic protection. You see what the mechanism behind the cathodic protection. So it is used to prevent or reduce the corrosion rates, of course. Then corrosion is an electrochemical process resulting from the formation of cathodes and anodes at different positions on the metal surface. Actually, cathodic protection works by connecting the reinforcement to another material that is anodic in relation to it. The reinforcement becomes a cathode and its corrosion is substantially reduced. So there are two systems. One is the sacrificial anode and another one is impressed current. Actually, in sacrificial anode system, the material of the anode is more reactive than the metal in the structure. Example, zinc or magnesium. The anode is consumed in preference to the reinforcement. In impressed current system, what we are going to do, the anode material itself may be inert but is maintained in an anodic state relative to the structure by being connected to the correct pole of direct current power supply. An outline of the process is shown in the figure. You just see in this figure. The anode is distributed over the surface, either an inert metal mesh or conductive coating, or many discrete anodes are fixed in drilled holes in the concrete. Then it is usually carry out a commissioning survey once the system has been activated to check the reinforcement is achieving the required degree of polarization. Often a permanent monitoring system is installed to check the system is continuing to operate successfully. So this is the impressing the cathodic system. So then coating to concrete. If we give the coating to the concrete, what happened? This is the another method against the corrosion or for corrosion protection. Here environmental pollution. If we give the coating to concrete, for the purpose of for protecting the concrete against the environmental pollution, industrial fumes and contamination of ground, the reduction in depth of carbonation of the protected concrete. Yes. So with this, I just conclude this video lecture. In this video lecture, we have seen very elaborately about the corrosion. Okay. So thank you.